Good afternoon, and thank you for joining our first Massons Digital webinar. It gives me great pleasure to run this. So I'd just like to shout out to Massons Director Anton Carrick. So Anton brought the first CAD/CAM system into Orthotics Australia. Then we were not Massons, but Orthotics Australia, which was the AMFIT system in 1996. And following this in 2000, Anton introduced Tracer CAD, which then, as we understand or know it now, is the Omega system, which changed in 2013. It gives me great pleasure to introduce and hand over to our Massons Digital team, who will today talk about some of the Massons Digital offerings and how Massons can help with bringing all your P&O dreams to digital reality. So today we'll be covering scanning. We'll talk about some design and look at some design software. We'll talk about materials and processing. And then we've also got some clinical examples as well at the end. So without further ado, I'd really like to hand over to Lewis, who will lead us through scanning. We'll have a section at the end of today that we can ask for questions, and please put all your questions, write them down as we go, and we'd really like to chat and open that discussion up at the end. So, as I say, without further ado, I'll hand over to Lewis and go from there. Thanks, Lewis.
Good afternoon, everybody. Lovely to see so many faces in the chat. So I graduated from La Trobe with my master's in O&P in 2019, and have since moved into a bit more of a digital space than patient-facing. So in the Massons Digital team, I sort of sit as the liaison between the clinicians and the technical side, helping with a lot of the 3D scanning as well as the design work. And so today we'll be kicking off with scanning. And so I want to start the conversation with what you should really consider when you're choosing a 3D scanner for orthotics and prosthetics. Seems obvious, but the first thing you need to keep in mind is what is it that you actually want to scan? Depending on certain scanners, you might be able to have more success scanning certain body types, and some scanners are rated particularly for some body shapes more than others. So consider exactly what it is you want to scan and potentially what it is that you might want to upskill to scanning in future. Next, it's important to consider the surface detail and the potential texture of what it is you're trying to scan. Is that something that's important to you? It may be or it may not be. It really just depends on what you're ending up doing with the scan, but just keep that one in mind. We also want to think about the portability of a scanner. Are you keeping it in the clinic? Are you trying to travel with it? Do you need PowerPoints? Is it completely wireless? So based on where you're planning to do your clinics and where you're planning to do your scanning, that can be an important factor in choosing which scanner to use. Probably one of the most important ones that you'll come across is your budget. So budget really does determine how much you can spend on the scanner, but it's important to remember that the more you use a piece of equipment, the cheaper it gets over time. If you end up transitioning to quite a fast digital workflow, you can pay off scanners quite quickly. But if you're maybe looking to dabble into it and dip your toes in before really committing to something with a fair cost, maybe something a bit cheaper will get you in. Regardless of what it is you're doing, garbage in is garbage out. It's a very standard engineering principle, but it always applies to 3D scanning. So all that really means the quality of your output is determined by the quality of your input. It really doesn't matter how much money you spend on a scanner, because when it does matter how much money in terms of, say, quality or things like that. But regardless of what scanning you have, if you don't invest the time into learning and practicing, it might effectively become an expensive paperweight for you. So always keep in mind, you need to practice and invest the time to get good at scanning and understand how it works and how to succeed so that you can get the best outcomes for your patients and also the best experience for yourself. So how do we judge a scanner's performance? I've really broken it down into 3 metrics that I think are useful. We're looking at the quality of the scan, the tracking capability of the scanner, and how accurate it is. So to break these 3 categories down a little further, for quality, how good is the surface quality of the scan? And is it accurately reflecting the surface texture of our scan shape? Some lower grade scanners, you might get a little bit more lumps and bumps, versus in higher end scanners, you'll get to points of millimeters of detail. So depending on what you're working on, you might not need that really fine fidelity. So just consider that when I mean quality. It's not necessarily good and bad, more about what does that surface look like. When it comes to tracking, it's really how easy is it to actually take the scan? And if you fall off the scan, because sometimes your hand moves and you slip and you're suddenly not where you were. Is it easy to get back on? So in some of the lower end scanners, the tracking capabilities might not be as well programmed as ones that are on the higher caliber. And finally, we have accuracy, which is arguably the most important of all three. How closely does your scan actually match the physical shape? And is the volume correct, like bang on, or within a reasonable percentage? So dealing with things that are closed shell front and back, volumetric accuracy is really, really important. But for maybe something like a crush box, a couple of percent here and there might be okay. So you could use something that's a little bit less high fidelity. So on that, we're going to break down three types of scanner that improve in quality, tracking, and accuracy as we go up the line. So at the most baseline level, we've got true depth scanners, which are also just known as phone scanners. And in our case, it would be through the Massons app. And so these are using the lenses on the camera that are used to match your face to log in to take a 3D scan. The second type of scanner are structured light scanners, and at Massons we have the Einstar scanner. So we're moving a little bit more up in terms of that quality, tracking, and accuracy. And then when we get to the top of the line scanners for O&P, we have white light scanners. And at Massons, our flagship is the Shining H2 scanner. All of these scanners can be viable for a bunch of clinical scenarios, but it's more just meaning that as we go up the line, we do tend to get better fidelity in the scan, the tracking gets a bit better, and they get more accurate as you go up the line. So I want to talk a bit about the pros and cons of each scanner. Great thing for the app is if you have an iPhone, you can scan, and it's not going to cost you absolutely anything out of pocket to get started. It's also completely wireless, and that makes it really portable. Your phone lives in your pocket. If it's well charged, you have a few hours of battery life. So really fantastic if you're on the road and you just need to scan something really quick. It's also got some color capture in it. It's not perfect photoreal colors, but it can get you some general landmarks. And you can also submit your files directly through the app, so you don't have to plug your phone into the computer, put the files on there, and then email them somewhere else. You can email files to Massons for exporting directly through the app. So it's a really portable way to get started. The Einstar is quite a small build, so it's fairly easy to handle. It's about as big as holding it in one hand. It's very portable given that it's got a smaller build, and it does have full color capture, so you're going to get photoreal color textures with these scans. It's also built in with an infrared mode for dark or shiny surfaces. My experience has been that in O&P, we do occasionally come across these scenarios where scanners struggle to see what they're looking at. And so the Shining products are built with this infrared mode, which just gives you another tool in the toolbox to help you out. When it comes to the Shining H2, it's the highest quality scans that we can take. And we can scan absolutely anything. The H2 is designed to scan for something as small as a coin to as big as a car. So for O&P, it covers absolutely everything that you could possibly want. Compared to everything else in the line, it has unparalleled tracking. If you come off the scan at any time, it knows exactly where it was based on the shape or markers within milliseconds. Like the Einstar, it also has an IR mode and full color capture. And it does also have the capacity for semi-weight bearing or full weight bearing with the foot station module, which, the long story short, is effectively a system of mirrors that mean that you don't ever have to get under someone to scan the foot. You actually go top down and the software stitches it together. It's unparalleled when it comes to getting that kind of scan. It's also optimized for live scans. So the H2 has a non-rigid algorithm, which just accounts for a person's micro movements here and there. Some lower end scanners with their software can struggle to pick this up as well.
Oh, I see.
And the final pro of the H2, it's cheaper than other white light equivalents on the market. It's actually about less than half of its closest competitor. Being a new kid on the block, it's up-to-date technology, and you just get a really good bang for your buck with that scanner. So conversely, we'll talk about some of the drawbacks on each of these scanners. And one thing to keep in mind that they're not necessarily cons as in you can't use them. They're more things to keep in mind that might be a limitation that mean that you need to look at one or the other options. So starting with the app, it does have the slowest scan speed of all of them. So you do need to be quite careful and considered while you take these scans. Falling off a scan often requires restarting from the app. This is mostly due to the limitation of it being a phone and having all of the computer software solely for a phone and not an external graphics card or something that can help run it. You do have to scan screen forward unless you're using a mirror attachment, and this is just due to the cameras that are actually taking the scans are the ones that normally scan your face. So you need to use a mirror if you want to look at the screen, but I have met many clinicians now who've just perfected the art of holding their hand the right way. They know the distance around the shape and they can scan without even looking at the screen. There are some limited shape types when it comes to scanning on the app. We would recommend it more for lower limbs and crush boxes than anything else. There can be some volumetric issues when you get to things like cranial helmets, but a lot of it as well, technique, especially for lower limb prosthetics, you can get some good scans out of it. It also only works on an iPhone. So sorry out there, Android fans, that technology is not in those phones yet. And so if you don't have an iPhone on hand or one in the clinic and you want to try using the app, you'll have to get your hands on one. The good news is that it runs on iPhones several generations old, so you can pick up one for fairly cheap if you need to. So moving up the line to the IronStar, it has a slower scan speed and tracking compared to the H2, but it is still a bit faster than the app. Unlike the app, which is fully wireless, it is tethered, and that means that it has a USB cable running to the computer and a power cable running to a wall adapter. This does mean it also requires a high-quality computer with a good graphics card to function, but you will find this as a feature on almost any high-end scanner that isn't a fully standalone unit. It's also not considered viable for cranial scans, so if you are looking to take those scans, we'll need to move up the line towards white light, but it can be useful for almost any body type otherwise. The H2, moving on, it does have the largest upfront cost of the three. And so especially if you're working within a more limited budget, getting to white light can be considerably expensive. And that being said, again, it is still about half the cost, if not less, than its equivalents on the market. Like the IronStar, it is also tethered, requiring a high quality computer with a good graphics card. Again, not necessarily a con, just more of a consideration. If you're moving into digital CAD/CAM as well, it's always good to have at least one computer with a high quality graphics card. It does have a larger build than the IronStar. It still is a single handhold move around the shape. So getting behind plinths can be a bit harder the bigger of a device you get, but it does still have relatively short barrels compared to other white light scanners as well. So looking at the file output, now we haven't talked about this so far, but we're looking at the two ones on the left there. They're two different file outputs that we can get from our scanners. And it's really important to consider because we need to know what are your scans doing when you take them. We know what we're doing when we take a plaster cast, is that we're either sending it to somebody or we're filling it. So think about the same thing when it comes to digital. Are you doing in-house mods? Are you sending them externally? Do you want to get this carved? Do you need to get it 3D printed? What you do with your scan will be very important for what file types you require. Is the surface texture important? So the two examples we have here, one of them has the surface texture captured as an image and the other doesn't. It might not be important for your work. Some providers might actually require it. So it's important to know based on what you're doing with it, either what you need to use it for or what the next person down the line you're handing it to needs. Some scanners do have proprietary export file types, so they can only be used in very specific software. And this is why we're very happy to say at Massons, all of our 3D scanners have open source outputs at no additional cost. And by open source outputs, we are referring to STLs, which are the raw shape, and OBJs, which are the shape with an image. These are both considered universal file formats, and there is almost nowhere that won't accept an STL or an OBJ, especially in O&P when it comes to getting devices made or doing modifications. So we're quite proud at Massons that all of our scanners are that open source. We would love to do some work for you, but we know that it's a wide world out there and we need to send scans wherever they need to go. And so we're absolutely happy to facilitate that. So really, we're at the point of the golden question. What scanner is best? The real answer is the best scanner is the one that matches your needs and your budget. If you want to start testing the waters and you don't want to really spend anything, the Massons app is a fantastic way to get started. And it's especially good if you want to do lower limbs and crush boxes, especially given that most of the time those are shapes which have a bit less risk associated with them too. Great way to get in and get started. If you do have a bit of a budget and you're looking to maybe upgrade from the app as well, the IronStar is a fantastic place to upgrade or really get in on a little bit of a higher budget than, well, nothing if you have an iPhone. It's really great if you've dabbled in scanning before because you've got a bit of a handle on what the limitations have been. If you've used the app and you found, oh, I wish that this was a little bit easier. The full color scan is fantastic for capturing markings on a cast. It is suitable for pretty much everything too, but the one major exception is cranial scans. So if you want to scan absolutely anything at all at the highest quality, the Shining H2 is going to be the scanner for you. It is also, from my experience and so far my experience in the community, it has been the optimal scanning experience, being able to pick up a scanner and have it work the way that you want it to work. About half the cost of comparable white light scanners. So if you've used one before and you're looking to maybe upgrade to something new, the H2 is a fantastic way to move. It's also ideal for cranials. Most fabricators will not accept structured light or iPhone scans. White light is considered the gold standard for cranial scanning. And with that as well, we do quite a lot of work with Invent Medical. They've done a lot of independent testing on scanners and have rated the Shining H2 as their #1 recommended scanner of choice. And so if you don't want to take our word for it, you can take Invent Medical's word for it. But really, at the end of the day, we'd love for you to come and chat with us to discuss which scanning solution is right for you. We want to find a way that you can get your goals achieved and your patient's goals achieved in a way that best matches your actual needs. So this is a bit of a spider web map, but just to give you an idea of the various 3D scan pathways that you could see even at Massons. So regardless of which of the input types you send, we've got so many different pathways we can take, depending if you're doing prosthetics or orthotics, if you're doing cranials, and the different softwares that we use to achieve that as well towards the final outputs. We use a vast variety of software to achieve almost any kind of clinical case that we can work with, as well as running directly through Invent Medical for some of those devices like the Tali, Piro, or the Orgo. Out of all these software, though, today we're going to be taking a focus on CADMed. And so for that portion of the presentation, I'm going to hand over to our designer, Leon.
Hello, everyone. My name is Leon, a 3D digital OMP designer. This is the design segment. In this part, I will introduce the main applications and basic operational processes of CADMed. Let's get started. Right, the current main application areas of CADMed include FO design, AFO, and SMO design. It can generate carving models for milling machines or fully digital product models for 3D printing based on the user's needs. I will show you step by step how CADMed can quickly modify and design models. At the beginning, we can see that the CADMed interface mainly consists of the left area, the left floating area, the central model display area, and the right area. The left area is mainly for adding functions after importing the scan models, such as import, marking reference points, smoothing, and so on. The left floating area is used for perspective control and displaying function settings, such as selecting the viewer, showing or hiding the different models, or making measurement. The central area is the main model display area, where all the editing and observation of the model take place. And the right area contains editing commands for models that have already been processed. This includes, but not limited to, heel raise, adding posting, deformation, and the function for preparing the model for 3D printing. Now, let's begin by watching how I quickly design an FO product here. During the import step, we can see that there are many options to choose from. You can adjust sighting based on your needs. I will provide a detailed introduction to this in our design webinar later. So after importing the scan model, I will mark reference point to help software recognize the model and place it in the correct position. Then I will correct scan data as needed. You can adjust the perspective and the areas that need to be rotated according to specific requirements. Very easy, just click a button with what you want. Finish that. We need to align the scan data with the templates in the software. So once finished, you can simply click the perfect fit button to pair your model with the template, or just like what I'm doing right now, you can make future edit to the template before doing so. After clicking the button, you can see the template will fit to your model perfectly. Yeah, and then you can further edit the initial install design, such as adding the deformations or add your own design elements in these steps. After making all the necessary deformations, you can click the solidify button to convert your install into a model ready for 3D printing. You can adjust the trimline or add the bottom surface for that. So this is only the basic install design process, but CADMed has many more features to explore. If you are interested, I can provide a more detailed introduction in our future design webinar. So this is the AFO design. The initial workflow for AFO design is very similar to that of FO. During the import step, choose the options you need, and there are many presizing available to select from, or you can design your own template and presizing, and then choose it in the later steps. AFO design also starts with marking reference points, but there are more points to mark compared to the FO. The more accurately you mark the points, the more anatomically accurate the scan model modification will be. Then you can start adjusting the model. As I mentioned earlier, the accuracy of the modification is entirely depends on the accuracy of your markings. It will deform the model with high precision based on the areas you want. The adjustment here are just simple demonstrations. In actual use, you only need to make adjustments to the specific areas that require modifications. All you need to do is just select the area you want to choose and change the angles numbers you want it to be. It is very fast, easy, and obvious. Next, we need to pair the model with the template, making sure to align them as close as possible by using the button to move the original scan data in the left floating areas. Yeah. Yes, very obvious to move it out. So once the fit is completed, you can continue to set the accuracy level. For AFO, I typically set it between 80 to 100% to achieve the most accurate skin fitting data. And there are also many functions in this type to play with to make sure you get the ideal AFO model. You can also adjust the hue height according to your needs. Yeah, just same with the modification, click the button, finish that. Or you can also make any other modification similar to the FO design as well. There is a very big library of the presetting of the modification. You can just choose according to your need or create your own. Then we need to solidify the model. The most important step here is setting the trim line and the thickness. So we have to manually adjust the trim line to divide the model. Here, you need to adjust the different perspective to ensure that trim line is correctly positioned. You can just create some new control point and drag it to the right position. Just what I'm doing right now. In this way, you can control the trim line very smoothly and accurately. By using the different perspective, you can see how to correct the position of the control point. And finally, we need to close the trim line to cut the model. Yeah, so you can see in this step, it's already cut it. The full model is divided into two parts. We just need to choose the correct one for us. So even after this process, you still need to adjust the trim line as you need. And the software will cut it automatically in real time. So that function will save us a lot of time during our design. Yeah, and you still can check and have a comparison between the design and the original scan data. And next, I need to create a hue stabilizer. I use the extrusion tool, similar. You need to define an area to set up the shape you want to extrude. So once it's finished, you still can drag the control point and control the shape you want. And then extrude it to the floor. You can see the trim line divided into two parts. You just need to click invert button to select the right area and smooth it to the desired level we want. Yeah, fast and easy. Even already finished the design of the extrusion, you still can do the similar way, just like what we did with the trimline. Just drag the control point and easy to change the shape for the stabilizer as well. There is a little tips. If you plan to print it, use MJF technology, we recommend setting up a lattice structure to reduce the weight of thicker areas. So these steps are the same as with the trimline and extrusion functions. Set up the areas and drag the control point and click the button. Yeah. So after finish that, it always take a while to generate the lattice. We just skip it to save our life. Yeah. The waiting time depends on the ability of your laptop, but it's normally around several seconds to 1 minute. So finally, the result is pretty good. We got a very cool lattice structure while reducing the weight, and this lattice structure also can help us lower our printing costs as well. And it's ready to export and print in the printer. Awesome. Yeah, next I will show you what happens when you save your previous design as a template. I previously designed a product and saved it as a template in the software. Now I'm ready to input a new scanned model and use my own SMO template to generate a new one. Let's start. So first you need to do is find the template file you saved from import interface. Then select the deformation you prefer. Then same with the normal process, we mark the reference points. The SMO reference point is similar with the AFO. Yeah, and then when we need to fit the model with our template. So after you click the button, it will take a while, but you can see it designed the final product directly. This can save us a lot of time on repetitive design tasks. I will introduce this feature in the upcoming design-focused webinar. If you are interested in this software or would like to learn more, please join the following webinar. Next, let's welcome our 3D printing expert, Nick, to explain Massons Healthcare 3D printing solution. Thank you.
So my name is Nick Scoville. I've been in the prosthetics and orthotics industry for around 15 years. Started with Click Medical, worked with them for about 10 years, and then worked with Otto Bach in the States as one of the cranial remolding specialists in their IFAB department. And now I am the 3D printing expert, according to Leon, but mainly the manufacturer and the operator of our MJF equipment. So MJF, what is it? Multi-jet fusion is HP's proprietary technology that uses their expertise in printing to create some of the best 3D printed parts on the market. Let's look at the steps that are involved. First, powder is deposited in a consistent and even 8-micron thick layer. The black dots you see in the table represent unfused powder. Next, fusing agent is then applied where you have previously designated parts to be produced. Simultaneously, detailing agent is applied to help mitigate heat at the edges of the fused part. This is MJF's secret sauce and helps to create smooth edges and highly detailed parts. That single layer is then exposed to an array of heating lamps to fuse the parts. The table drops 8 microns, and this process gets repeated up to 5,000 times for a build that is 380 millimeters tall, with each layer taking around 8 seconds to complete. In this video, it's going to show you in detail the individual steps that are taken to create fused parts using MJF. And again, the fusing agents for the parts, detailing agents for the edges, and heat lamps to fuse all of those layers together. And there you have it. All right, so MJF, this is not really your typical 3D printing technology. Now, we all know what FDM is, and if you don't, it stands for Fused Deposition Modeling, and it is essentially a hot glue gun mounted to powered guide rails. FDM was the first commonly known type of 3D printing and the one best suited for home users. It has its place in the 3D printing world, and we love it for a quick pair of insoles. But MJF printed parts offer far superior structural properties compared to any filament-based technologies. Because with 3D printing, it all comes down to layer lines. While MJF does have them, they are 8 microns thick and play far less of a role in strength due to near perfect layer adhesion, as well as the ability for the operator to optimally orient the part. With any 3D printed part, if a failure is going to occur, it will almost always propagate from the point where 2 layers join. You can see in the diagram that an FDM part has good strength in the X or Y axis, but strength will always be compromised in the Z axis, which is exactly where this FDM printed socket failed. FDM is great for some things, but at this stage, Massons does not think it's suited for any long-term weight-bearing devices. Now for our materials, what are we printing with? PA11 nylon is a rigid material that's known for its strength and its flexibility. It has superior flexural strength and it is far less brittle compared to its cousin PA12. This material is also sustainably sourced from castor beans and it is fully recyclable. It is an excellent choice for AFOs, TTs, TFs, and any device that needs to mimic devices that are traditionally made from carbon or rigid thermoplastics. This material is also biocompatible and it is well vetted in our industry. The other material that we are currently printing with is BASF's TPU. TPU is a rubber-like material. It can be bent and stretched. It has high wear, abrasion, and tear resistant, and is an excellent choice for flexible liners for most O&P applications. TPU has a high new powder to recycled powder rate of 80%. What that means is that 80% of the total powder used for any part is made from recycled material from the previous builds. So for post-processing of 3D parts, when you place an order for any 3D part from Massons, you will have the option to vapor smooth them. What that is a surface finishing application that fuses the outside layers of the print to increase isotropic properties, as well as improve the surface finish quality. Devices will have a smooth finish after processing and resemble an injection molded part. This process will turn the part jet black unless it's been previously dyed. For TPU, this is a necessary step to increase tear resistance and give the part a smooth finish and increase the material's ability to repel liquid. A couple cost reduction tips. Hollowing out your part. Please hollow out the center of your designs. It can help reduce the amount of material that you're using and reduce the overall weight of the finished device. Don't forget to add escape holes to allow for powder removal. While support material is not a concern when designing for MJF like it is for FDM, being able to remove the powder from any internal cavities must be thought about. And another one is latticing. Well-designed lattice structures can help reduce the weight of your part significantly while retaining structural integrity. Remember to leave adequate gap space, about 1 mil, and design so that powder removal is easy. This is especially important with TPU prints due to the unique post-processing requirements. And keep in mind that the insoles you see in the image above can have a top or bottom layer printed with them and are easy to glue a top cover onto. Just to go over a few of the just general MJF design guidelines, and this applies to really any powder printing process. So MJF walls that are designed too thin are at a high risk of warping. We do recommend a wall thickness of at least 1 mil, and you want to avoid overly thick walls as well, as they can lead to an uneven or pockmarked surface. Adding a lattice structure, when you're doing that, you want to have adequate clearance to make sure that there's easy removal of residual material inside the part. The recommended minimum gap size in a lattice structure is also 1 mil. For any embossed features, they must be designed using a minimum height to ensure visibility and to prevent the detail from wearing off during post-processing. We recommend a minimum height of 0.5 millimeters. And now for engraved features. With MJF, text and engraved details are at risk of closing up and won't appear visible if not designed with a minimum depth and width. We recommend a minimum depth of 1 mil and a width of 1 mil. I hope that's given you guys a good overview of the materials that Massons are currently printing with. We will be doing a more in-depth webinar discussing materials in the coming months. If you want to know more about that, keep an eye out in our weekly newspaper or social media posts. And without further ado, I will leave you in the hands of one of our star clinicians, Danica.
Thanks, Nick. Good afternoon, everyone. I am Danica, one of the clinicians at Massons Healthcare. So my role today is going to be going over a few case studies with you where I have fitted some of our in-house 3D printed devices and just explaining how the services that we've provided in those cases have been beneficial for the clients compared to traditionally made devices. So this client of mine is a 50-year-old lady who presents with right side hemiplegia post-stroke. Growing up, she was incredibly active, and through sport, she experienced a range of ligamentous damage to her left and her right ankles. Her primary concern was her foot drop on the right side. Previously, she had worn a traditional articulated AFO with tamarack joints and a plantar flexion stop. But with this device, her biggest concern was that she found the device really heavy, bulky, and she struggled with heat during the summer. So I'm in a very fortunate position where I have an expert digital manufacturing team here with us. So leaning on their expertise, we designed an AFO, actually the exact AFO in the image above, with the goal of giving the client all the support that her traditionally made AFO was providing, but improve the weight and the breathability. So this case was actually the first in-house device made using 100% only digital design and manufacturing techniques. Instead of casting, I used the Massons 3D scanning app to take a semi-weight bearing scan on a glass scanning board. To modify the scan, Willowwood's Omega software was used, and then for the AFO design, we used CADmed. There was little upskilling and time investment for myself as I was already accustomed to using Omega and the Massons 3D app. However, I relied heavily on the digital team when using CADmed for the design. Similarly to our CFAB process, I uploaded my modified scan, gave the digital team my design and fabrication instructions, and then we organised a time to go over the design prior to printing. With little changes needed to the design, the most difficult part of this process was actually incorporating the joints and keeping them well aligned to each other and to the model, because back when this was done, CADmed was more or less in its infancy. Since then, we're very happy to have worked closely with them to develop the software to make it much more functional. And now, compared to then, it would be a much simpler process. In our first attempt at designing this AFO, we printed the AFO on the left of screen. Once printed and vapor smooth, the proximal shell had far too much torsional flexibility, which we anticipated would lead to premature breakdown around the joints if worn daily by the client. The second and final attempt has an X-shaped reinforcement to give the proximal shell more stiffness while still providing sufficient ventilation and minimal added device weight. The device has been worn by the client for around 11.5 months now, with no signs of material breakdown at the joints, at the forefoot, or anywhere we would expect to see breakdown in an AFO after it's been worn repetitively for around a year. The second case study of mine is a gorgeous little 2-year-old boy. He was referred to us from his physiotherapist for orthotic assessment to provide a device that would help support his left foot and ankle, enabling him to walk independently. He had been cruising since he was around 12 months old, so we've had pretty much a 12-month period of stagnant gross motor development. And when he did try to walk independently, we found that his body weight was just causing his left foot and ankle to collapse. Our goal was to provide a device that would provide support to his foot and ankle without restricting his range of motion and impacting his other functional activities such as crawling. So based on this, we fitted a flexible SMO made out of TPU. As you can see in the video on the right, taken at our initial fitting, the device did a really good job at correcting his foot posture, but he still wasn't quite confident enough to take those steps independently. We saw him for a review 2 weeks after that appointment, and he ran through the front door. His mum reported that 2 days after the fitting, he was walking by himself very confidently, and he quickly progressed to running. He's now been wearing the device for around 4 months and showing continuous improvements with his physiotherapy. We're hoping that pending his strength and stability continue to improve, we can progress him to wearing a pair of foot orthoses potentially and getting him out of his SMOs as he ticks off his gross motor skills. So similarly to the last case, this client's leg was scanned using Massons 3D app, but in a non-weight bearing position. The model was adjusted and the SMO was designed using CAD/MED with no joints or complicated design processing. The entire time spent from converting the IMED file to finalising the device was less than an hour. So this was really efficient and easy to fit into my busy schedule. And then I just wanted to finish off my part of this presentation with some things to consider so you guys can all learn from my mistakes. I wanted to include a few images to other devices that we have designed, but my first bit of advice would be to work within the outline parameters set by the digital team. Things like recommended thickness, trim line tapering, reinforcements around joints and ventilation regions are all important things to make sure that you get a really nice functioning device. In one of the first AFOs that we printed of mine, I tried to taper down my 4-foot thickness to around 0.5 mil, and as soon as we've gone to vapor smooth it, it has warped massively. So here's a little tip from me, don't do that. Secondly, start simple and work your way up. My first full handful of devices were foot orthoses and solid AFOs. Building confidence in the technology, the materials, and in the design takes time. And with limited information on performance and durability with higher end orthotic componentry, it's difficult to know how the 3D printed devices compare to those traditionally made. Saying that, since we've started introducing them into our own clinical practice, we've made significant advances in both our design and our manufacturing journey, with more complicated and more advanced products being produced with really great trial success. Finally, communication is key. The communication with your client as to how a 3D printed device differs to a traditionally made device, what their expectations will be. Communications with the digital manufacturing team, if you're getting it CFAB'd, are so important to make sure that what you're wanting from your device is what you're getting back. And finally, feedback through all those communication channels mean that not only will your device exceed expectations the first time you do it, the next one will be even better. And actually, the last one that I want to chuck in is don't be scared to get creative. 3D manufacturing opens up avenues to be creative with designs, reinforcements, aesthetics, materials, and so much more if you're open-minded enough to look for innovative solutions. I will say in my case, it's also really important to have a team that can bring you back down to earth when you get a little ahead of yourself. So lean on those around you who've got experience in it. And I can say confidently that the Massons Digital Team and myself are more than happy to go over anything that you guys would like to discuss. I'm actually going to pass back over to Phil to head us out.
Thank you, guys. So from my point of view, I think I just wanted to do a little quick summary before I open the floor to questions. Massons uses and provides a range of digital solutions and services, and we aim to cover all your needs, allowing you to leverage the power of digital workflows at all levels of your practice. We have a full gamut of scanners, as Lewis has just gone through. We have design softwares. Lewis highlighted a number of softwares, and then thanks to Leon, we had a quick look at CAD/MED. We have a number of options in terms of our printing as well. And I think that it's really nice that we can see that we can make your theories come into real life. Using digital doesn't always mean 3D printing, and we offer CFAB carving for traditional manufacture as well. So if you want to scan and then modify and then move back towards a traditional manufacture, we also carve. And the advantages of carving, of course, is lightweight. So, you're not having to move around heavy plaster work and things through your workshop, making it much safer. However, we do also, as discussed, see the future in 3D printing. We have over 3 or 4 printers, and our HP 5200 MJF is our flagship printer, which Nick highlighted, including our AFT vapor smoother. AMT, sorry, AMT, not AFT. We also have FDM printers, and coming online in July, we will also have the latest in the Voxel Care pallet printer for foot orthotics, which is pretty exciting as well. If you're looking to enhance your clinical services, and please contact us. Our Massons team is ready to go. We're here and willing to help with all your digital workflows. And I'd encourage you to reach out either via the phone or through our info@massonshealthcare.com.au email address. So from here, what I'd like to do is open up the floor to questions. Shane has just popped a question in the chat for us. So is the CADMed software in the cloud, or do we need to purchase it? So the short answer is that no, it's not in the cloud, and no, that you don't need to purchase it. So the service itself, and I might actually throw to Lewis here because he's actually even better at describing all of this subscription service than I am. So Lewis, are you happy to answer that one?
Yeah, I'll say so. At the moment, CADMed exists as a pay-per output model. So depending on how much you export is how much you end up paying. I do not believe, you could correct me at the moment, that there is an outright cost to get started. There might be. We might need to clarify that one. But yeah, it's a significantly low cost compared to other output systems, and there is also a bit of a grace window, I guess you'd call it, if you want to change the design. So it's not so much every time you output it consumes a unit, which are like some other softwares consume immediately. It's more billed at the end of the month. So you do end up with a grace period to repair some designs if you decide, oh, I should have changed something before I export it.
Correct. And just to highlight that, so that that file output is a file output for us to carve, for instance, versus you can also then take that through to a 3D print design for a 3D print output. So two layers there with the CADMed software. But correct, at this stage, as Lewis said, there's no subscription fee. It's a pay per output.
Another benefit I've just mentioned a benefit as well is everything you design in CADMed, you can save as a template. So everything, even if you've exported it before and you didn't make it a template, you can open it back up in the software and save it as a template. And what we mean saving as a template means that this can be scaled to another model. So as you saw Leon putting the points on the model, particularly first, fifth, and heel will help automatically scale these models to match.
I can see that Yvonne's got your hand up. Yvonne, would you like to unmute yourself and ask a question?
I do. Can you hear me? Thank you. Yep.
I sure can. Yes.
Lovely. Thank you. Thanks for that. That was a great presentation. So we currently have, I'm going to say, the equivalent of the H2 scanner. I don't know if it's, I don't think it's as new as that one, but we've got that in our department. I'm at the Alfred. And we are using it a lot for facial, mostly for faces, for burns, face masks, but also I think we've done a few AFOs with it. What I'm interested in is I do a lot of complex diabetic footwork, and you mentioned earlier the foot station model or module and the use of mirrors and things so you don't actually have to get under the foot. So none of us have been brave enough to go ahead and make foot orthotics yet with it. So what would be the recommended, like, is that scanner the best one? And what is the actual foot station module? And are you able to elaborate a bit more on what that actually entails and how I would go about using it?
So at least at the moment, the foot station is specifically designed to pair with the H2. So I don't believe it would pair with the Omega that I think that you have. Yes. Yeah, so it is something that at the moment it's a Shining exclusive add-on to the H2.
Right. Is there something for the Omega, like if I wanted to make foot orthotics with it, or not really? Is there, or do I just scan it like I would for an AFO, but then just cut the, when I'm modifying it, just cut the image down to just the foot section?
Can I just jump in?
Yeah, I thought
there is scanning plates that TechMed sells some scanning plates, which are adjustable in angle, and whether you have the person sitting in the chair and then you can take a semi-weight bearing scan with the bodies, like the body scan or the Omega scanner is a creaform scanner. So TechMed do sell some scanning plates which can be used with those two scanners. So we can send you
Right.
some more information on those plates.
Yeah, we have a perspex board, if that makes sense, like on a 45-degree angle. Is that what you're meaning? Like a
Yeah,
clear perspex board? Yeah. So we just scan under that, and then we would make the foot orthotic from that. Is that right? And then you would just, yeah, only capture the parts that you need.
correct.
Yeah. Okay. No worries. Thank you.
The other,
difference
yeah,
between-
you could scan a foam impression box if you wanted a semi-weight bearing scan.
Yep. Okay.
But that's throwing.
Or
Yeah,
scan a cast.
you can scan the cast. Yeah.
I would say as well, we have had fair success in merging scans. So say if you took a scan with a cast, just so that we know in relation to where everything is, especially if you do fiberglass and there's a consistent thickness, it can be fairly simple to reduce the thickness of that cast out, take a crush box scan and actually replace the foot with that, so that you know that everything's in the right position. Yeah, there's multiple ways of stitching together if you can't get it in one either.
Okay, thank you.
The other option that you can do is also to scan the person lying prone, so that you have that full access. But yeah, the Technerd plates work as well. So yeah.
Yep. Okay.
The benefit of the foot station module is more or less like a box that the person puts their foot on top of the box, and it's got a mirror within it and markers so that the software knows where the mirror is in relation to the foot. So it just means that instead of having to go under the plate, which is what you'll be having to do with your current scanner, they can just foot on the ground and you point down. And because pointing down is effectively reflecting the white light onto the bottom of the foot. So and then the software does all the hard work of stitching what ends up being more or less two separate scans. Because of the way the module is calibrated, it knows to flip the bottom and stitch it on appropriately.
Okay,
there are videos, we've got videos up on our Instagram showing what that module looks like in action as well.
Yep. Great, thank you.
Ali's asked, has the Shining H2, does it require tokens to process individual scans? So I'm pretty excited about this one, and I'm probably taking a bit of shine off Lewis, but no, it doesn't. So the scan, once you have a H2 scanner, it comes with a free software package that allows you to export an STL or an OBJ file straight out, no tokens per scan at all. So that's a one-off cost for the scanner, includes your software, no subscriptions for the software, and you get that STL OBJ universal file output, scan after scan after scan. But I'd just like to take the opportunity to thank everyone for joining us this afternoon. Hopefully this sort of gives you a little bit more background into our Massons Digital Team and also our capabilities. But we would also really encourage you to reach out and chat to us. We have multiple webinars that we run in our education sessions, and in the lead up to AOPA this year, we plan to have a little webinar series which will further deep dive into some of the digital world that Massons is and has. So please keep an eye out for that. Hopefully everyone gets our newsletters. But without further ado, I'd like to say thank you so much for everyone joining us. Thank you for our digital team sitting there all very nicely in their shop there. And reach out through info@massonshealthcare.com.au for any questions.